Afternoon. We're the next talk. We're going to be presenting Vitaly and I on the we're calling the blockchainware, decentralized malware on the blockchain. A bit before we start discussing a bit the subject of the topic, we're going to make a small introduction about who we are, what we do, the organizations we belong to, and then we'll move on into explaining a bit what is the topic. There's a proof of concept that will be shown a bit quickly for everyone to have an idea about what could be the possibilities regarding this potential threat, and then we'll close down for questions at the end with possible solutions and ideas.
Before we start, just let me ask you, how many of you are using Bitcoins or other cryptocurrencies? Can you please raise your hands? Let's see how many enthusiasts are here. Any developers or supporters of the community of Bitcoin or other cryptocurrencies?
Cryptocurrency developers?
No?
Okay.
Do you know what is Bitcoins at all?
Okay.
Okay, that's why you're here. I hope so.
That's nice. Okay. Okay.
Oh yeah, let me help you.
Quickly.
Okay, quickly, next.
So, for a start, this is actually a talk focused on the work that we've done at Interpol. For the people who don't know Interpol, we are an international organization of 190 member countries. We're not a police agency, we're actually an organization, so we don't have an international jurisdiction. It's a bit different than what you see in movies. It's not James Bond. We're going to come back to that later on. But we are actually based in Singapore. So Vitaly works for Kaspersky Labs, and I work for Interpol, but we're actually based in the same building in Singapore. What you can see now here is our new, what we would call our Interpol Global Complex for Innovation, which is a complementary siege building for Interpol because the main general secretariat is based in France. This building is focusing on cybercrime. So this is basically Interpol's response for cybercrime threats around the world. The official opening will be on April 13 next month, but we have already been operational and we've been working here in Singapore for the past, in this building since October 2014. We're not James Bond, as we mentioned before. I mean, this is not what you see in movies. We don't have guns. We don't run with guns.
Officially.
We don't chase people in cars. We don't do any of this stuff. So our main core business is actually supporting our 190 member countries and their police organizations when they need to share information, so then we can actually relay and facilitate cooperation between member countries. Talk a bit about us. So my name is Christian Karam. I'm a cyber threat researcher. I come in from a penetration testing background. I'm an engineer. I work for Interpol for the past 3 years now. I work in Interpol. I more or less manage all the functions for threat research for the organization. So we'll talk a bit later on about some of the programs that we have and we're doing. But I'm going to pass it out to Vitaly.
My name is Vitaly Kamlyuk, and I'm a principal security researcher from Kaspersky Lab. I've been with this company for almost 10 years now, and I mean, I like my job. What I do is mostly reverse engineering, analyzing advanced cyber attacks. And by the way, have you ever heard of the Global Research and Analysis team from Kaspersky? No? I'm a member of this team, so I'm wondering what people know about Kaspersky. Do you know what we do at Kaspersky? Do you? Can you raise your hands? Those who know Kaspersky Lab and research we publish? Not so many, very good. So it's good that you can at least learn and have a reference what is our job. So what do you think we do, by the way? Any volunteers? How could you summarize it? Just shout loud. Malware analysis, cool. Kind of, but you are wrong. In fact, officially to some popular media outlets, what we do, we are going to the Banya with normally Russian intelligence officials, because the company was founded in Russia, and this is what they claim we are doing. And when we are not in Banya, which is a Russian sauna, from time to time we do an APT research, which is advanced persistent threats. I hope you know this term as well. So we are analyzing targeted attacks, and what you see here is kind of a logbook and every ship here represents a campaign, a cyber espionage campaign that we haven't covered. And most of these, maybe 90% of these, are nation-state-sponsored espionage campaigns against different countries across the globe, including Russian-speaking attackers. And if some of these names, like Stuxnet, Equation, Red October, Finspire, Flame, rings a bell, I would recommend you to go and check all the others, because there are a lot of other ships that are advanced persistent threats that we have researched and made public. So this is where you can get the same logbook. It's an interactive website where you can click any of these APT boats and go read about some technical details of our research.
Some of the stuff that we do overall also is actually focusing on several research projects that we have developed in-house. Some of them are key for problems that law enforcement is currently having. Our core business is actually focusing on detecting future threats or early detection, and potentially look at future scenarios that could potentially go very wrong for the communities. One of the biggest focuses we have is actually research on darknet. We've done massive work researching darknet, actually looking at both aspects of traffic, and the second aspect is actually content data and how criminal aggregations are developing in this specific space. So we can see a bit how it started to boom in 2010 and how it's migrating to different structures up to 2015 today. We have actually developed in Interpol several different mechanisms to actually see threats and trends over darknet, and we have now developed the first international darknet training, simulation training for police officers that would allow them to actually commit the crime virtually in our closed space. So they would actually build their own marketplace, their own networks. We have our own virtual currency in a closed test net. They can actually run the crime, commit the crime, learn how to manage the escrows, just become criminals for 3-4 days, and then they will be the capture the flag type of model where they'd have to take it down. So we're moving into more of a active training type of thing, going to simulations rather than anything else. Another area of focus is obviously what triggered this whole talk today is our work that we have done in cryptocurrencies, mapping different cryptocurrencies and crypto assets, working on them and seeing how actually it might become a cyber enabler of crime. Like any other technologies has been developed. I mean, dynamite has been developed for a good reason, and what turned out to be also has been misused for bad reasons. So like any other technologies, it has a good edge and a bad edge. Unfortunately today, fortunately today, we're going to be highlighting in our talk some aspects of awareness that are very important for the future development, the healthy development of the technologies that we do believe in as great innovations, focusing basically on the backbone of the cryptocurrency universe.
Can you guys read anything from this slide? Actually, can you go back? Can you read anything from this slide? Can you read text? No? It's too small, right? There are so many. It's actually the universe of the cryptocurrencies. All different coins, crypto coins, are displayed here. And there are so many cool ones like Dogecoin or Bunny Coin or Titcoin or any others. And there are so many cool things about all these coins, and all of them have own features and now own advantages. But let's move on. Our talk is not about that.
Yeah. So this presentation today is not a vulnerability disclosure, first thing I would like to say. It's not something that is more a vulnerability, it's a potential misuse. It's not a manual on how to write malware. It's not giving ideas about how to write the malware, so we want to be very clear on that. And it's not an attempt to subvert cryptocurrencies or actually blockchain innovation. So we're not actually addressing Bitcoin or any specific cryptocurrency here. We're talking about the backbone that is protecting, this actually enabling the transactions, or actually the main infrastructure for enabling all these cryptocurrencies to survive. Blockchain is the key innovation. A lot of different companies today are working on blockchain innovation, decentralized software, decentralized potential ideas are excellent and they're great for the communities, but also we're going to highlight a bit how this can be misused so that we can also spread awareness a bit about that subject.
A long introduction, but what is in the focus of our presentation is this, the blockchain. So how can you interpret the blockchain? I like the smart idea of how you can explain what is a blockchain in a nutshell. In simple words, the blockchain is the core of cryptocurrencies, of every cryptocurrency, including Bitcoins. So we're not only focusing on Bitcoins at this moment, however, our presentation will show something related to this network, but this is about any cryptocurrency. So what is a blockchain? Blockchain, treated as a ledger, public ledger, the book where you have all the transactions written. Every income and outcome is written in this book. And the beauty about this network based on blockchain is that this is public. It is not stored at any single computer, at any single authority. Instead, it is distributed across thousands of computers around the globe. So everybody has a copy, and everybody can look inside of this ledger and see where transactions were, where the money were coming from, where they were going. However, the wallet IDs are normally anonymous. They are just hashes that are not bound to physical IDs in the physical world. So having this, we thought about the ways of how this can be misused potentially. So we want to foresee and predict potential future threats and address them before they have developed. So going more into details of how Bitcoin, as an example, and the blockchain works. In fact, the name blockchain stands for the chain of blocks, right? What is a block? Block is a piece of data. It has a header. It has a body. The body has a list of transactions, which actually correspond to the money transfer initiated by one of the participants. In the beginning, there was the genesis block, the block which inputs some bitcoins that they can be reused or shared among the participants of the network. So that had to be some initial input. That was a genesis block. So on each blocks, they linked one to another by storing a hash. Every next block will store a hash of a previous block so that they can be verified and linked, and you see the chain of blocks in the end. There is also some mining math. So the participants of the network, they have to do certain calculations to confirm that a new transaction that is added to this public ledger is valid. They have to provide a proof of work, and they do some math. And they go further. This math is pretty interesting by itself because it's actually can regulate, based on the number of participants in the network, how complex will be this task that every participant have to solve to confirm that certain transactions are valid. And that is done through the thing that is called the nonce, the number that can be adjusted based on the number of participants in the network. If there are too few, the task is becoming less difficult. If there are too many participants and this task can be cracked quickly, then it will be more complex by adjusting this. So in the end, we have a chain of these blocks, and every participant which confirmed the validity of the block with a list of transactions can get rewarded for his proof of work. And this is how people can earn new bitcoins. This is called mining, by the way. So in addition to that, there are some transaction fees. So every transaction that is made can have a kind of a change that is paid to the miner which confirmed the block of transactions. So all of these changes from each transaction are collected, and this is going to be added to the reward of the miner who confirmed the block. There's another interesting concept like Merkle root, but if you're interested in math and hashing functions, I'd recommend you go read that. Just a nice concept and innovation. So essentially, what do we use to store arbitrary data in the blockchain and how it can be abused after that? So what you see here is the transaction packet. Essentially, these are the fields, mandatory fields of every transaction packet. Starts from a version. There is some bytecode representing the transaction input, and then the bytecode representing transaction output. So if you think that in each transaction there is a wallet ID of sender and recipient, it's not the way how it works. It's more flexible than that. Instead, they store some kind of a bytecode in own language, own instructions that can be processed, and that gives the network the possibility to change the hashing algorithm or to increase the space for the wallet ID or change anything else. So in fact, you have to go and run this bytecode, extracting the wallet IDs from it. And this is where the user can enter any data. Another beauty of the Bitcoin, this is an example of Bitcoin transaction, is that when you transfer money to someone, you don't need to care whether this someone wallet IDs exist for real. So you can actually transfer to somebody who gave you his wallet ID, but the network cannot confirm whether this wallet is real, whether the person exists. So you can transfer to someone, and that someone can come and claim the money years after the transfer. This is done through the strong cryptography, the asymmetric cryptography, the digital signatures. But the flow, security flow in this, is that you can store any string in the wallet ID. Okay? For example, the first wallet could be something like this. That will be the second wallet. So you put some text strings, and in fact, what you get, if you combine all of them, you get a story, okay? Which you can interpret and you can deal with in your own bank. I mean, it's up to you how you interpret and how you run the data that is stored in the wallet ID.
And this is currently permanent. So if this is actually uploaded and signed on the blockchain, there is no actually any way to actually wipe it from the blockchain or revert it unless the miners themselves who are confirming the transactions do not confirm this specific transaction. So the data does not go on the blockchain. I'm going to show some examples of data that we have found on the blockchain. So the blockchain currently sits as a bootstrap file, so you can download it and you can actually examine the blockchain as a whole document. This is an example of transaction that we have seen on blockchain.info, which is a blockchain explorer. You can find it online. A specific transaction ID that you can see at the top corner on the left. This is actually a normal transaction that has been made, but the intent of it is not about actually transferring money. The intent is actually storing two different components. One is an image and the other is a text. So it is actually the picture of Nelson Mandela that was stored on the blockchain in more of a hex format. And the second one is...
Just a moment. Let me interrupt you. Just for those who don't understand what it is, this is actually a screenshot from
the blockchain info.
From the blockchain info, which actually represents you the transaction in a more readable form, not in the binary. So on the left, you have the source wallet. On the right, the destination, the recipient of the transaction. Okay.
So these are basically the wallet that actually sent the initial transaction, which is the singular wallet that you see on the left. And the ones that were sent out on the right are actually the wallet addresses that are actually hosting the data that was sent, that is hosting the different set of data that has been shared. So part of it is the image that we will see now, which is Nelson Mandela's picture, and the other part is a famous quote that he had. He had said years ago that they wanted to preserve eternally on the blockchain. So this was, for example, one of the data we were able to find. Other examples, we can go through. Some of them is actually just the Bitcoin picture as an image, a JPEG format, was also found on the Bitcoin blockchain. There's also Lance Saman, a black hat speaker as well in 2009, a cryptographer from Belgium, KU Leuven. Unfortunately, this is a tribute that was done by Dan Kaminsky as well, who was a black hat speaker in 2011 and 2009. He uploaded this tribute for a land because he actually died. Recognizing all the work that he has done in the cryptography world, he actually wanted to pay a tribute for him. He left out a small ASCII design for him. There. Some other examples, you can see in red is the specific transaction. This is the transaction ID. Well, again, this is what makes it a reference for it, for the data. So the transaction ID is in red. What we followed as well is actually the same design, the initial wallet address and the several wallet addresses. Here you can see it actually uploaded the data and shared it among 185 wallet addresses. So you can see there's actually a massive amount of data that has been expanded into different sections. But this example is actually a QBasic code for a game that was also uploaded on the blockchain. The code is available there in the same format, and it can be retrieved off the blockchain, specifically here in this case. Other examples we found in a specific transaction. The first Bitcoin paper written by Satoshi Nakamoto in 2008. the trigger, the inception of this whole business. So it's also hosted there in PDF format, so it can be recovered and then from these different wallets. Pictures, also random pictures by people were hosted there. Just some examples.
This is stored in thousands of machines. Run Bitcoin.
Yeah, those are just stored data that has been sent there. Interestingly, we found also WikiLeaks cables. So some examples of cables that have already been published and have been actually uploaded on the Bitcoin blockchain, permanently again available over the Bootstrap file and the blockchain itself. We've seen several other type of documents. There's a massive amount that is encrypted by nature, so we cannot actually figure out what it is. So we need a lot of time to maybe understand what has been uploaded there on the blockchain. But generally, what interests us is actually explaining the whole concept, how we injected a code into the blockchain. And here what we did is there's actually a script that allows you in Python to inject and retrieve data of it, but we used another service that allows us to automatically just input the data. You have to make a payment, a transaction in Bitcoin, so you have to pay in Bitcoin. The bigger the amount of data that you're trying to upload, the more you have to pay. But the donation is not something, we call it a donation because it's more or less not something very expensive. It's relatively something very small. Here, the example that we did is actually, you can see pay to. We inputted the wallet address that was going to retrieve all the data and then push it up into the blockchain and distribute it on several wallet addresses. We put an amount that I wanted to have and the details of the stream of data that I wanted to upload. This is on the mobile phone, the transaction confirmation that happened. So we made a payment from our own wallet, a separate wallet that we have, into this specific address. Here you can see two different transactions. March 19, the value is 0.18 euros and 0.16 euros. We'll talk a bit why is that in the next slide. But the average time for confirmation of a transaction currently sits at 11 minutes. So we had to wait 11 minutes to actually see our data being uploaded on the blockchain, on part of the blockchain. So this is the stream of data that we were able to see. If you look at the bottom, you can see that there's someone that actually uploaded as well random data on the blockchain that you can see. They mentioned, hello, this is Rabbit. I can't see it from here. I'm getting old.
This may be a test. Maybe not. All your bases are belong to us. Remember that with great power comes great responsibility. Taco Commander.
So Taco Commander is an unknown person that posted data on the Bitcoin blockchain.
Useful message to the future generations.
An excellent message for the future generation. And something we want to highlight here, and we want to apologize for the miners and the blockchain community that our intent here, we published the code twice. It was not actually to, we are very careful about not misusing the space or actually wasting the space available on the blockchain because it does cost them a lot of work and a lot of time. And it's more of a subject of data pollution. So the first time we uploaded, if you see March 19 at 13:30, there's the code that was uploaded. I uploaded the code, but I could see there was a 1 that was added at the end. I thought it was more of a typo, so then I uploaded again another time, and it added 14. So for some reason, when we uploaded the stream of data, and this specific stream of data is actually a shell code that's going to be is actually pulled out of the Metasploit framework. We'll talk later on about it.
But the true reason I think that why Christian has uploaded it twice is that he just wanted to upload it at some lead time. If you read the timestamp on the top, it's 13:37, right?
Yeah. Well, that was not intentional, but that would happen, so it's a good story. You can see that the value of it was 0.002 and 0.0015 Bitcoin, so the value is not something massive again, but this is a small part of code that can be pushed out there, and we can see actually how much other people have paid for the uploads that they have done, so we can actually see how big the amount is. So again, we took the transaction ID that we have because once you make a transaction, once you make a specific transaction, we can keep the transaction ID. We took it again with us. The data was uploaded on the blockchain. It resides there permanently now, and then we were able to visualize it again on the blockchain info. the initial wallet address and then the several wallet addresses that are hosting the data, that are sharing the data that has been posted there.
Well, I guess this is a term that we have invented, blockchainware, a software that can bootstrap and run from the blockchain, taking part of its executable code and executing in memory of your machine. But I guess just in a nutshell, what it is, a blockchain, put simple, there's some code stored in the cloud, which is a network of peer-to-peer network running the Bitcoin. And that can deliver you the payload, which can be a benign application, can be useful. At the same time, it can be evil application delivering something to attack. So, enough of words. Are you tired of talking? Us talking? You want to see the demo? Yes! Try again. Yeah, finally. Okay, you deserve a demo. All right, so I'll start my... It's a live demo, yeah, it has to fail. Let me see. Okay, it doesn't work from start. Okay, I have to move the virtual machine here. Okay, Windows. Nice. So here's what I got. The executable, bcware.exe, and then the CMD file. Can somebody read what is in the CMD file? It's an executable name and then a couple of parameters, quite long. You can see one hash. This is the hash or ID of the block that I'm going to fetch with this software. And then the second is the hash of the transaction that I'm going to search in this block. And then I find the transaction, I extract all the wallet IDs, I convert it to binary form, put it all together, and execute as a code in memory, okay? Very simple. So let me run this CMD file now, and I hope that the network works, because this is going to be live. We'll now fetch the code from the Bitcoin network. And if you're wondering what this code is, it's quite short. Let me show you. Okay, now it's connecting to the network. You can see my network icon is blinking. Now it's downloaded and shows this message box displaying the original code that is actually glued from the wallet IDs. So this shortcode is basically a shell code taken from Metasploit. It's a simple shell code to run external applications. So this one is quite benign. It just launches the notepad. So if I click OK, it will be executed. Okay, we got a notepad running from the blockchain. Surprised? No? Okay. Come on, more applause, because this is the first demo from Interpol. Come on. Thank you. Thank you. So if you want to make sure that it doesn't have any reference to the notepad and have not hard-coded anything inside, or just make a simple check. I'm sure this is not very trustworthy for you. You know, it can be obfuscated, but just as an easy check, we'll search for the notepad using hex editor in the binary. It's not there, okay? So if you want to see the original shellcode, shall I show it? Am I allowed to show it?
Yeah.
Do you also write it?
Share today, share.
Okay. All right. Let me move it here. Let's see. We'll do the hex dump. There is a notepad with a header. Oh, this one is fetched from the blockchain. So in hex, so I just cat. Okay, and then I'll convert it to the binary. Okay, and then to the hex dump so that you can read at least the ASCII strings. Okay, you got the shellcode, not rendered well, but you see the notepad exists here, so I hope that that's enough. So, well, but considering that you know how the idea works, I'm pretty sure that it's not a question of trust whether it will work or not. It just should. Okay, we're back. All right, let's go on. So what? Yeah, so what? So what do we got? Basically, just imagine now that you have a modular malware that is linked not to one transaction, but it actually combines and follows up certain wallet ID and fetches new transaction, fetching new modules and new code. and you cannot actually predict what this software will run tomorrow with the new transactions added to the blockchain, right? And in fact, this can be used for zero-day distribution, because 0 days are normally not as big, comparably, and they are quite perfectly fit the size of the space that we have. And the maximum size of transaction, and the whole block actually is limited currently with 1 megabyte. It's pretty a lot. So you can actually submit it to the blockchain and encrypt it using the public key cryptography to make sure that nobody cracks unless he has a private key. And then you can sell the private key to the buyer. So it's theoretically possible. This is what we can predict how it can be abused. The follow-up.
One idea that we've been entertaining for a while and been really looking into getting confirmation of this is that there has been many different attempts for underground criminals to move into creating what we would call private key marketplaces, and this could be the gateway to fuel that. So you don't have anymore to open to have a marketplace where content is actually known. You just move into just selling private keys. So private key would be extremely valuable today because it allows you to unlock data, and actually you can start fueling the malware sale over the internet. But also it could go into child sexual abuse material. So you can have a lot of data like child pornography pictures that are actually uploaded on the blockchain. This is massive amount of data pollution that could be uploaded there. It could be massive misuse, and also it could be sold in the encrypted format for now.
Well, let me stress on something here, because this is critically important. The scene here is that once you upload it and once the network confirmed the block, you cannot pull it back. You cannot remove it. It will be on the public ledger forever.
Permanently
until the whole blockchain-based cryptocurrency is shut down. And this is about money. This is bitcoins, right? They are not going to be shut down soon. They will be supported by individuals. It will run for many years. And you cannot pull this data from it.
And this is going to be potentially a massive problem, because if you're uploading data that you can never take down, it's a child sexual abuse material, it's still available if it goes public, and it's available with a set of private keys that are also is available, you will actually be distributing child sexual abuse material for different people. And this is going to be quite something problematic, because the daily struggle of a lot of police officers and law enforcement communities is actually to take down this material that is potentially not wanted over the internet by any community. Other aspect also that is very interesting for us is that, and this is why we apologized again for uploading our data twice, is that we are very much aware of the value of the blockchain. I'm a Bitcoin miner myself, so I have a lot of respect for this technology. I didn't want to say it in the beginning, but I think it's
okay to say it in public. You couldn't say it in private, right?
It's not going to kill anyone. But just a small idea is that the blockchain, the size of the blockchain, the bootstrap file itself, not long ago, it was only around 7 gigabytes of data. Today, it sits at 25 gigabytes of data. Less than a year ago, it was 7. So we can see how it's bloating. Part of it is actually good for innovation, because we can see a lot of companies moving into creating services and innovation on the blockchain, which is something good. But if we see also a lot of data pollution or misuse of the data that is being uploaded on the blockchain, that's resource extensive, that's making it also very difficult to actually use this space efficiently.
So now about some conclusions made from it. What is important about all this? What is important for the bitcoins and other cryptocurrencies from this talk? What is important from our perspective is the balance. Cryptocurrencies have to keep this balance. There are systems that are based on central authorities. There are central authorities in the physical world who can regulate, who can enforce certain actions. The whole story of the cryptocurrencies went the opposite way. They have a decentralized system, allowing any participant equally contribute and do something independently, without central authority, without the bank in the middle. Okay? What we wanted to do, and what makes sense to do, is keep the balance between the central authority and decentralized system. Because otherwise, it will lead to the data pollution. If anyone can contribute, anyone can flood and actually pollute the database. Can inflate the database with the garbage, like pictures you have seen, the documents were uploaded that you have seen, maybe even malware or child sexual abuse materials. So it has to be partly sustainable system or recoverable system. Okay? This is what we have on the opposite pole. Otherwise, it can become just a purely criminal tool. And we don't want it to be a criminal tool. Nobody wants it to be a criminal tool except the criminals. We want it to be a tech innovation, a useful tool designed and used for good. So we want to stress here that we support the idea of cryptocurrencies. We are not struggling against it. But it has to be done in the proper way. It has to be designed in the way that it is not abused by such things that we have shown in our presentation. So, talking about the solutions. From the end user perspective, for the antivirus companies like Kaspersky that I work for, it's easy so far. We can actually blacklist all the applications that can download something alien, something unknown from peer-to-peer network, such as cryptocurrency network, and then just forbid it to run. Just stop it in the beginning, even without the payload. Want to continue?
Well, from a network perspective, for the blockchain network perspective, again, we talked a lot about this. We need to keep it very hygienically safe, very important. The value of the network is actually based on the number of nodes that are operating on it, the traffic that is running through it, and also, very importantly, the type of data that is running through it. So if there's more data that is very harmful that is being channeled there, the support from other communities might be a bit different. It might lead to some imbalance in the support, and it might lead to actually not developing the blockchain technology the way it should develop, because it is a massively important technology that has immense potential to change a lot of things that we have today in this world. Another perspective that is very important for us is from developers' perspective. People are actually involved in designing cryptocurrencies. I am very sure that if they're developing cryptocurrency in mind, they don't want it to be also an enabler of crime or an enabler of potentially something that would allow them also allow people to actually host data that is potentially very harmful or actually reverts back to illegal material. So there needs to be a very good discussion between cryptocurrency developers. We're not providing these solutions. We're going to keep it very open for the community. We want the community to come up with a solution itself because it is self-regulated. So they need to just think about the requirement of not wiping data off, but is there any way maybe we can work as security, because I work initially in research innovation, so I'm not at the policing back end, but more in the research and threat detection back end, as well as antivirus companies as well. If we can detect these anomalies over the blockchain and we push them out to cryptocurrency developers, could there be a way where they can actually clean it up or actually find a way that would enable them to actually develop a system, a mechanism that would negotiate not having the data permanently there, or before it actually is signed, they're completely block it before it is permanently signed on the blockchain. So what we're talking about is mainly either pre-miner revoking, the miners revoking the transaction before it's actually signed permanently, or any other options that they might have in mind. I'm pretty sure that the community can come up with very excellent solutions that are very innovative and very healthy as well for the cryptocurrency world. Yeah.
And this is the end of our presentation. However, we have one more thing for you. Well, first of all, this is the first ever presentation by Interpol at Black Hat, at the Hacking Conference, which is an interesting thing, interesting change from my perspective. And we got greetings to pass from our special communications and data encryption department from Interpol. And to be honest, I don't practically know what it means, but let me just leave it here. Maybe you can go figure it. With that, thank you very much. We are ready to answer your questions. With one exception, I just wanted to make it clear, we don't know who took all the money from Mt. Gox. Questions?
Question in the back.
How much pollution we have at the moment? Can it absorb? Okay. You want to answer? Well, from my perspective, and I looked into the protocol, it's just up to the polluter, to be honest, because you have to spend some money to get the transaction validated. So it will cost you little, probably cents. So how much have you paid? Less than €1.
Like 18
0
cents.
cents.
Wow.
And one block is up to 1 megabyte. So this is the speed using which you can, I think, inflate the blockchain. So 1 megabyte per 10 minutes, you can count yourself, I guess.
So how big is the blockchain now?
It's 25.7 gigabyte, but it's still expanding. But the idea of it is actually that Bitcoin has specific characteristics and features. Other coins are actually based, or they have enabled characteristics or enhanced characteristics that allow you to host more data in a specific block. So some of them might be more of a specifically tailored for that purpose, so that actually they are designed to host more data than others. There's no limit currently because the blockchain is very elastic. There's no set amount, so it's expanding basically at the rate of the miners. The more you mine, the more blocks are going to be created, so the more space will be allocated. The only scenario where the blockchain would be growing very, very slowly would be if miners stop mining now, or actually would mine at a slower rate. But that's not happening because actually that is delimited by the what we call the difficulty of mining. So today, if the difficulty of mining is high, your rewards are slower and are shorter because now they're changing based on the initial Bitcoin algorithm. But the difficulty drops when different conditions are changing, specifically in the cryptocurrency from economic perspective. So it always adjusts itself in a way that it keeps it developed at a certain rate.
Any other questions? Okay, we have first.
Similar research on the type of decentralized, for example, Twitter-based malware, where it would be non-consistent, but it was interesting for
Okay.
kind of malware.
The Twitter-based malware. We have seen that malware before, right? So there are bots that can be controlled through the Twitter messages. So they go online and fetch certain Twitter messages. Then they decode and decrypt using the key hard-coded in the malware, and they use that as a command to be executed or followed on the infected host. So there are such examples of malware. But this is something different because in Twitter world, and this is a resource from the world of central authorities. The authority would be the company running Twitter, right? So they can go and pull out all of these messages. They can block the account. They can delete it, preventing the bot herder from controlling those machines. In the blockchain world, in the cryptocurrency world specifically, there is no way to pull out the transaction. Otherwise, it will circumvent the whole idea of independency and having no central authority.
I mean, that's why we wouldn't assimilate the same reaction of Twitter-based malware to the blockchain-based malware, or blockchainware. The idea of it is that it's there permanently and signed. There's no one that is available who can knock the door of the blockchain or go into the blockchain and say, I need this to be scraped out. So all the solutions would probably be at the user end, but when it comes to cleaning the chain itself, the data itself, it cannot be done currently. Whereas on Twitter, there is always the authorities that could come up and delete the data or change it or edit it or whatever it would be.
Wait, another question there. So again, the payload is what?
Would the payload affect the miners?
Okay.
Yeah. So potentially, the payload could be anything. We just showed an example of a notepad being triggered here, but the ideas of it, you might have a botnet in the future running over, or just having the repository data based on the blockchain. You might have different examples of, all the current applications that you have seen of malware in the real world, in the same world, but I would say in the standard way, you could have it as well on the blockchain. So it's not a question about miners. It's not going to attack the miners themselves because it's on the blockchain.
That's right. Just to make it clear that the miners are not going to execute this code that is put into the database, right? But the miners are going to keep a copy of the whole blockchain, which may include malware and maybe child sexual abuse materials. And are you happy with that storing on your hard drive? So you probably don't know how to extract that, but there are people who can. There are applications which could, and that basically means you are participating in distributing those materials. And I would be not okay with that. Not sure about the others.
Yeah, just to be very, very clear on this so there won't be any confusion. It's not because it's based on the blockchain that it would affect the miners specifically. I mean, there could be in the future specific malware on the blockchain that could target miners, and we have seen already some other type of malware not on the blockchain that targets miners specifically. But for that time being, I mean, the possibilities are endless. Basically, anyone could come up with a new type of malware and new deployment methods, and it could be very persistent and could stay a very long time and could be targeting anyone, and that's the main concept of it. Yeah.
Any other questions so far? Oh, we have one.
You said that the more data you upload, the more expensive it is. Do you know how much 1 megabyte costs?
The question was, the more data you upload, the more expensive it is. In fact, I don't think that's related. I mean, it's just a cost of transaction, and the miners can actually reject verification of a certain block if it's not valuable enough. If you don't pay enough, they may just reject the block. Nobody wants to, not to get paid for.
That's why initially I used the word donation rather than a payment, because again, when you're uploading data on the blockchain, there would be a set minimum to give, so it would be more of a set minimum donation that you need to give, but there's no limit on how much you would actually want to pay. So you can pay 1,300 Bitcoins, or you can pay the set minimum that could be, in 1 megabyte we haven't done the calculations, but it wouldn't be something massive. It wouldn't be something really expensive. Any other questions?
Other questions?
From a cryptocurrency perspective, is it possible to control the data as you were saying?
It is possible for the miners to revoke a current request for a transaction to be signed permanently on the network. So before the transaction is actually verified and stacked in the ledger, it is possible to block it. But that would be not effective for people like us who are doing the detection after it's actually hosted. So the data is there. If we do the detection, it already has to be there so we can actually detect it. But what we're actually proposing at the end would be that from a developer's perspective of cryptocurrencies, that's an open question for the community. Would they be willing or available in terms of discussing as a community a functionality like this that would, in specific cases and special cases where you'd be child sexual abuse material or specific malware that you don't want to be residing permanently on the blockchain, would you be ready to discuss something like this?
But by design of the Bitcoin protocol, at least, you cannot reject a transaction just based on the wallet ID because you don't like the wallet ID. It's kind of ridiculous,
Discrimination.
It's kind of discrimination here. It breaks the equality of participants of the network. Yeah. So I would say, it's hard.
So most transactions that are sent out are usually verified. Yeah.
Other questions?
Yeah. We are working right now because there's a lot of set of data that is actually encrypted. We're trying to find. We've seen a lot of rumors and allegations that yes, this already has happened, but we're yet to get a hold on this. I would assume that if someone is involved in pedophilia and sharing material, would not post it in a very open way. So they would at least try to encrypt it and upload the data in an encrypted format. So that is currently the challenge. So we're still going to do a lot of work on the detections of these things as well as malware. Yeah.
Other questions?
Okay.
No questions so far?
So far.
Then let me ask you a question. So would you like to go to Bunny with Kaspersky Lab? Now.
No.
Right after the presentation.
Okay. Thank you.
No? Okay, you need to hear it again. Let's start from the beginning.
Which one?
The presentation.
No.
They are not ready for the Bunny.
No.
Come on. Okay, gentlemen. Think again.
Yeah.
All right. Thank you very much for coming. Thank you for your time, and hope to see you next time.
Nice picture.